that were alive during the Permian period.
Same for animals.
And we also have breaking news about an extinction.
So let's get on to the news.
Today, the southern part of Pangaea is rapidly going underneath ice caps, while the northern part of Pangaea is going under extreme heat and dryness. It is estimated that in the next 200 million years, Pangaea's climate is going to change. Sulfur and carbon dioxide are going to be exploding out of volcanoes, while the sea levels in the land are rapidly dropping, and new species of coral and sponges are being found alongside with animals becoming extinct. And in the next 200 million years, while the climate is also changing, it is said that we might struggle breathing. And that's it for today.
This is Jane Identity, live from the Green Room, with breaking news on 5 newly discovered plants. Around 298 million years ago, the lycopsids dominated the lowland swamps and contributed the most organic matter to the vast coal deposits that extended over North America and Eurasia. If you think that's a long time, then prepare to be surprised. The lycopsids possibly existed as far back as 419 million years ago. That's a long time. Lycopsids are an ancient vascular plant that had roots, simpler branched stems, and small, spirally arranged leaves. Around the beginning of the lower Permian, the lycopsids turned into shrubs and eventually started dying out when the planet started drying up. When the lycopsids died out, they left room for a new species, the Glossopteris flora. The Glossopteris flora emerged in the southern hemisphere around the beginning of the Permian period. Not only were they the largest and the best-known genus of the now extinct order of the Glossopteridales, which are a large type of seed ferns, but they were the dominant elements of southern flora during the Permian era. Even though they were restricted to the middle and high latitude parts of Gondwana, these homogeneous plants were an important contributor to the vast Permian coal deposits in the southern hemisphere. Unfortunately, at the end of the Permian era, they went extinct. However, the Glossopteris flora wasn't the only species that contributed to coal deposits. The calamites, generally known as organtaxa, were the components of the understories of coal swamps. These spore-bearing plants had segmented, bamboo-like appearance and vertical ribbing on their trunks, while their branches, leaves, and cones had whorls. In fact, the calamites' needle-shaped leaves were up to 25 per whorl. The medium-sized, tree-like horsetails mostly grew around the sandy banks of rivers. While to the unassuming eye, these plants were normal, they had a nifty special ability. They had the ability to grow from underground rhizomes when the upper portion of the plant was damaged. Unfortunately, the species went extinct in the lower Permian. Another plant that has left amazing remnants on the planet is Walchia, a fossil conifer. Walchia fossils contain numerous four-legged tetrapod fossil trackways. The cypress-like genus was found in lower Permian rocks in Europe and North America, and they still exist today. In rural Nova Scotia, a forest of Walchia stumps live in situ. Having said that, the Walchia is not the only ancient plant species that are alive today. Enter the Ginkgo biloba, or as it's known more modernly, maidenhair tree. The Ginkgo biloba, which can be shortened to ginkgo, is a genus of highly unusual non-flowering plant. The species belong to the Ginkgolus order, which is still found in the wild today in China. The ginkgo grows best in disturbed, well-watered and drained environments, along streams and leaves. Because it evolved in an era before flowering plants dominated disturbed stream-side environments, the ginkgo was the dominant species in its time. The ginkgo had a habit of bolting, growing up to a height of 33 feet before spreading its side branches, which is what scientists assume it did to survive. The living fossil, as it is often termed as, has soft, weak, light-colored wood. Large seeds and its fissured, grayish bark have a quirky texture that is deeply furrowed on older trees. Now that you know a little bit more about the plants that lived in the Permian, Isabella will tell you all about the animals that lived in the Permian era.
An animal that lived in the Permian period was the Diplocaulus. It had a boomerang-shaped head, it weighed as much as a cat, and it was about as long as a yardstick. It lived in streams, rivers, lakes, and it skimmed on top of the lake when it would move, and it lived in what we now call North America. The next animal to live in the Permian period was a Dimetrodon. The Dimetrodon used its tail as a regulation device, and it also walked with a spade-legged posture. The Dimetrodon was known by various names like the Calypsodrops, and for decades the Dimetrodon lacked a tail. The next animal to live in the Permian period was the Helicoprion. The Helicoprion swam all over the world and was about half the length of a semi-trailer, and it weighed as much as a horse, and it was also known to possibly live off a diet of squids, and it was also known to be a vicious shark. Europs is another animal that lived in the Permian period. The animal lived in what we now call Texas, and it was as long as a tortoise, and it weighed as much as 3 Dalmatians, and it was a carnivore, which meant it only ate meat, and it moved at the speed of a turtle. The last animal you'll be learning about is the Xenacanthus. The Xenacanthus had a slim, elongated body. It also had a pointy tail, and fossils were how we discovered it. It lived in fresh waters, and it had a strong spine as used for defense against predators.
Do you want to own a rock from the Permian period? For $19.99, you can own something that was on Earth before the Great Dying. But wait, if you buy 3 rocks, you will get one free, and we'll even throw in free shipping. Get your Permian rock today. Call 1-800-PERMIAN. That's 1-800-PERMIAN.
Have you heard about the Great Dying? Well, after this segment you will. The Great Dying is one of the largest extinctions in the Earth's history. There are many reasons for why this Great Dying might have happened. One reason is that there was a climate change. The climate change is the most reliable reason for the extinction happening. The temperatures went from 25 to 28 degrees Celsius to 22 to 24 degrees Celsius, which also will decrease more in the beginning of the Triassic period. The ocean temperatures rise, which causes photosynthetic symbions to not be able to survive in warmer waters. The ocean might have actually went from 6 degrees Celsius to 30 to 32 degrees Celsius, which is a huge change. Another possibility for why the extinction happened was the carbon cycle change. It went from 12C to 13C, which is very significant. Due to this carbon cycle change, the biological cycle had to change. This carbon cycle changed a lot due to the change in carbon dioxide in the atmosphere because of anoxia. Anoxia also limited the amount of sunlight plants got, cutting down photosynthesis. Volcanic gases might have added high amounts of carbon dioxide in the atmosphere too. The change in the atmosphere also shifted the amount of organically fixed carbon dioxide that recycled in the air. A third possible reason for this extinction is because of the population explosion of methane-producing microbes resulting in extinction. There's a rapid blooming of the archaea called methanosarcina, which caused a dramatic rise in the Earth's ocean temperature. Nickel, which is released when a volcanic eruption happens, shows to limit nutrients from methanosarcina. This release of methanosarcina also has an impact on the carbon cycle change. Also, experts say the uptake of carbon dioxide in the oceans and the deposition of carbon in ocean sediments during the end of the Permian was for greater than that, which could have been caused by eruptions of the Serbian Traps alone. This hypothesis was proven in 2014. There was nickel deposits in China. The last possibility is that there was an icy impact that could have caused the extinction. There was a sudden cool on the Earth, which caused a glacial episode at the end of the Permian period. This cold rush caused the water level to go down. This changed the routines of animals and plants to have to change, but they couldn't adapt. You may not know, Pangea had an influence on all of these possibilities for the extinction. Now let me ask, do you feel like an expert on the Great Dying, the largest extinction in the Earth's history?
Do you feel like a Permian period expert?
Yeah, you should.
I hope you enjoyed our new show.
Thank you. Have a fantastic day.